Okay, here are your notes for Chapter 6, Chemical Bonding. We're going to talk about a little bit about what chemical bonding is, and then I'm going to show you your first set of formulas that you have to name and write formulas for. Okay, so just a couple of vocab words. Chemical bond should be one of your vocabulary words, so you should already have it. Or if you write it now in your notes, you can just show it to me and you won't have to write it again in your vocabulary. Either way works. Okay, so chemical bond is just an attractive force between atoms or ions, and it binds them together as a unit. Don't worry about this second bullet. Mostly you just need the definition for chemical bond, which is this first bullet here. Very important that you can tell ionic compounds from covalent compounds. All right, I'm just going to show you how to do that real quick, but you have to tell them apart so that you can use the correct rules to name them or write the formulas. All right, ionic formulas start with a metal. The first element in them is a metal. See, Na sodium is a metal, and with covalent compounds, the first element in them is a nonmetal. That's how you're going to tell them apart. So covalent compounds is a bond between two nonmetals. Carbon and oxygen are both nonmetals. And this one is ionic because it's a bond between a metal, Na, sodium, and a nonmetal, chlorine. If you look at our periodic table, let's remind ourselves how to tell what are metals and what are nonmetals. Okay? If you will remember, this little stair step kind of separates them. So all of these are metals, okay? And then these guys over here are basically nonmetals, okay? So remember our example was CO2. Carbon and oxygen are both nonmetals. That's why it was covalent. But in our other example, sodium was the first one. It's a metal, okay? Remember, metals are over here. Nonmetals are over here. So in order to tell what kind of compound you have, you've got to look on your periodic table and look these up. Okay? I have a couple more things I'm going to show you on this. I'm going to go back a little bit. Okay. So, starts with a metal, it's ionic. Starts with a nonmetal, it's covalent. Very, very important. Okay, two kinds of compounds that we're going to have. You're going to see binary compounds, which just mean there are two elements in them. So here's sodium and chlorine, 2 elements. And then you're going to have ternary compounds, which basically have a polyatomic ion in them, but they have more than 2 elements. So you can clearly see this one has sodium in it, it has nitrogen and oxygen. That's more than 2. So that would be a ternary compound. A couple of vocabulary words. I would definitely write this down. Definitely write this down as well. This is the previous slide. You need this. Write it down. You also need this. Make sure you write it down. Also, write this down. Very good notes. We talked about ions in the previous chapter. 2 kinds of ions that you're going to see are monoatomic ions. These are all the ones that are on the periodic table that I showed you with the charges. And then you're going to have polyatomic ions. I'm going to give you a list of these, and you'll always have access to the paper that has all the polyatomic ions on it with their names and, most importantly, their charges. You will not have to memorize these. You will always get to use that chart anytime we do any activities. So you'll have a list of polyatomic ions, and that just means more than 2. So, of course, nitrogen and oxygen are 2 or more, so that's why it's poly. Sodium is all by itself. It's a single element. All right, do not write all of this down, okay? All you need from this is this top part right here, okay? So under ionic, you need to know that E stands for electrons. You need to know that electrons are transferred from a metal to a nonmetal. It's very important. They're transferred. They give and take. With covalent, you need to write this down. Electrons are shared between 2 nonmetals. Okay, so covalent is shared and ionic is transferred. Very important. So write down only this top row right here. You do not need all this other information in this chart. You need this top row of bond formation. And you need to know for ionic and you need to know for covalent. You do not need this slide or any of this. That's why I'm going through them fast. Okay, we already talked about electronegativity. Okay, so let me pull up the other slide. You don't need a lot of this either. I know I'm skipping around. I kind of do this in sections and I skip around to the parts that go together. So the next thing I'm going to show you is right here, electron dot diagrams. They're very simple, okay, but you do need to know what they stand for. All right, these dots are showing the valence electrons, okay? If it's full like this, and there are 8, it must be a noble gas because they're the only ones that have 8 valence electrons, right? So this is showing valence electrons, okay? I'm going to show you how to do a couple of them. Octet rule, you should have this, but if you need to write down this first bullet, you can, but most of you are probably good with knowing what the octet rule means, and it's just that everybody's trying to get 8. We've already talked about it quite a bit, okay? But before we move away from this, I'm going to do a couple of examples with you. All right, when you're doing those dot diagrams, let's just take an example from this first row. Any of these in the first row. I'm just going to use potassium. So here's K. When you're doing a dot diagram, you're going to list their valence electrons around them. Think of them as having 4 sides. Here's a side, here's a side, here's a side, and here's a side. Well, these guys all have 1 valence electron, right? These have 2, 3, 4, 5, 6, 7, 8. We've labeled these guys before. All right, so since K has 1 valence electron, I'm going to give it 1 dot, showing it has 1 valence electron. It does not matter what side you put it on. I could have written my K like that. I could have written it like that. That's fine. I could have written it like that. You get the idea, okay? Just show that it has 1 valence electron. All right, I'm going to do one from this row next. And since I tried to say calcium a while ago, I'll just do calcium. All right, calcium, you write the symbol, has 2 valence electrons. So I cannot put them on the same side together. I have to put one here, and then I have to pick a different side to put the other one on. Okay? It doesn't matter which 2 sides. I could have done it this way. That's fine. I could have done it this way. That's fine. But now what is not fine though, this, if I put a dot here and then a dot here on the same side, that's incorrect. Simply because you've got to put a dot on each side before you start pairing them together. Kind of like the Aufbau principle, okay? So they have to be on different sides. It just doesn't matter which 2 sides, okay? We'll do boron next. Try to show you one of each. So here's boron. It has 3, so any 3 sides. 1, 2, 3. But it does have to be 3 different sides. Okay? So for carbon, you're going to see carbon a lot. It has 4. That makes it special. It means it's got 1 on each side. 4. 1, 2, 3, 4. All right. Nitrogen has 5. So this is the first one where you're going to see each side fill up. Okay, because see nitrogen, I'm doing nitrogen, has 5. And there's your 4, and then you can pick any side to pair on. But after you've put a dot on each side, then you start pairing sides together. It does not matter which side you pick to pair. Okay, so then oxygen has 6. So 1, 2, 3, 4, 1 on each side, 5, 6. That's what oxygen would look like. Then we can do fluorine. It has 7. 1, 2, 3, 4, 5, 6, 7. Only one side isn't paired up. All right. If I have any of the noble gases, they're going to have 1 on every side because they have 8 and they're happy. There we go. So those are pretty straightforward and it's pretty simple. Just electron dot diagrams. Okay. All right, you need to write these rules down. Matter of fact, we're going to stop here. I will do these naming rules in a separate video so that you can keep this stuff separate. So we will come back to this.